We also definitely want to knock out 3/6 and not even get a little bit of 3/7. So these are two short sections. In 3/6, we'll be doing what we did in 3/5, solving equations. It's just these are going to be word problems. So you got to sort of figure out the equations and then solve them, okay? So 3.6, solving applied problems. So I'm going to knock out about two of these for sure. I'm going to do one with triangles, and then I'll probably do one with the adding numbers and stuff. So for this example, I got triangle ABC. So we got a triangle ABC. So they tell me the measure of angle B. So measure of angle B is 4 degrees more than angle A. Then it's telling me the measure of angle C is 41 degrees more than angle A. Find the measure of each angle. All right, I'm dealing with the triangle. So I got three angles I'm worried about, okay? Remember, I need three equations to solve three variables. So let's see what they're giving me. First, they give me measure of angle B. So that'll be what? B equals, and then it's 4 more than angle A. So that could be A plus 4. Last name?
Smith.
Okay, Smith. Okay. All right, well, second equation they give me, angle C is 40 more than angle A, so that's going to be C would equal A plus 41. But I've only got two equations and I need three. So the third equation depends on what you know about the angles of a triangle.
180.
Yeah, so that's the one they want y'all to remember, that three angles do add up to get me 180. So A plus B plus C will equal 180. Now, before I start solving this, these two equations need those variables on the left side equal to their numbers, okay? So I got to get all my A's lined up, my B's lined up, and my C's. So on the first one, I got B equals A plus 4. I'm just going to subtract the A from both sides, get it drawn over, so that gives me a negative A plus the B is going to equal 4. And I'm going to write all my systems I'm getting up here. So I got negative A plus B is going to equal 4. Same thing with the second one. We need to get that A brought over to the left side. So that one was C equals A plus 41. So once again, I'm just going to subtract that A from both sides. So I get a negative A plus the C will equal 41. And really on equations, if you take something from one side to the other, all we're really doing is changing the signs on them. So I'm gonna put this in order. So I got a negative A plus my C is gonna equal 41. And then I'm gonna bring this last one over. You gave me A plus B plus C equals 180. I'm just gonna label my equations so we can keep up with them. So I guess it depends what variable we want to get rid of. We got A, B's, and C's. No preference. No, I ain't gonna worry. Just take a look. Hey, okay, I'm gonna get rid of the A's. So right off the bat, I can add row 2 and 3. Those A's will become. So I'm gonna add 2 and 3. Get rid of A. All right, so I got negative A plus my C over here equals 41. A plus B plus C equals 180. We did good, right? The A's are gone like we wanted. So that this gives me a B. C plus C gives me 2C. And then let's see, that looks like 221. So that'd be my equation 4 now. And then since I did 2 and 3 that time, I think this time I'm going to do 1 and 3. Because remember, I got to use 1 now with either of the others. But since I got a negative A and a positive A, those will cancel the A's also. So I'm going to add 1 and 3. Get rid of A. Okay, so when you use 2 of them, you got to use that third equation with either of the other 2 to get rid of that same variable, okay? Remember, sometimes you got to change those rows to get them to cancel for us. All right, so let's see. 1 was negative A plus B equals 4. And then A plus B plus C equals 180. But y'all, once again, the A's are canceled. Now I got a B plus B is 2B plus the 1C, and that's what, 184. That would be equation 5. So now I'm going to put equation 4 and 5 together and solve a system of 2 variables. So 4 was B plus 2C equals 221. 5 was 2B plus C equaled 184. So that's 4 and 5. So I need another letter to get rid of, and it looks like it'd be the same either way. Like the same amount of work on these. So I got 2 and 1 on one and 2 and 1 on the other. So yeah, give me a letter. D. So I'm gonna get rid of the B's. But notice, in order to get rid of the B's, I got a 2B here and a B. I'm gonna have to multiply row 4 by a negative 2. That way a negative 2 when I add to a positive 2 is gonna cancel those B's. So I'm gonna multiply row 4 by negative 2 and add to my row 5, okay? Now remember, everybody's got to get multiplied by that negative 2. That's going to give me a negative 2B minus 4C equals a negative 442. I can bring the other row down. I didn't have to change this one, so I got 2B plus C equals 184. I might break out the calculator on some of these. All right, so the B is no problem. Negative 2B, B cancels. Negative 4C and 1C gives us a negative 3C. And then let me see what I get. want to add that negative 442 plus 184. That's going to give me a negative 258. But y'all, at this point, I'm down to one variable, so now we can solve that. So I'm going to solve for C by dividing by the negative 3. What's that, like 86? And then all those negatives going to make it positive like I needed. But I do now know that angle C is 86, okay? So now I'm going to back substitute into one of my equations from section 4, equation 4 and 5. And if I put a C in, I can actually solve for my B, okay? So back substitution. So I'm going to put my C with 86 into the, y'all want 4 or 5?
4.
4. So I got B plus 2 times C, which was 86. That's going to equal, what's that, 221. Okay. So now I'm going to multiply, let's see, 2 times 86. So I get my B. 172. Sound good? That's going to equal 221, and then let's subtract that 172 from both sides and be done with this. So 49. I now have 2 angles. I know that angle C was 86, B was 49. And y'all told me a while ago that all 3 of these angles had to add up to 180. So I don't know A yet, but I do know that B was 49, C was 86, and that was going to equal that 180. So y'all really, I'm just coming back and plugging into equation 3. But notice, you could have got A from either one of these 2 also, okay? All right, so 49 and 86 is like 135. That's going to equal 180. Now, y'all, I'm just going to subtract that 135 and see what that angle A equals. 45. So I got an angle A 45, angle B 49, angle C 86. If I add all 3 of them angles up, they gotta equal 180. Okay. So these aren't too bad. You just got to figure out them first equations. So I'm going to work another one of these that's sort of where you got to figure out your equations, okay? So y'all got questions on that? Okay. Y'all been waiting on the ice, I guess, huh? So let me name off 2 of these and y'all figure out which one y'all want me to do. So one of the problems says the sum of 3 numbers is 58. The difference of the largest and smallest is 52. And the sum of the 2 smaller numbers is 13. They want me to find the numbers. This one says, by eating 1 egg, 1 cupcake, 1 slice of pizza, a child consumes 301 milligrams of cholesterol. If a child eats 3 cupcakes, 4 slices of pizza, they get 96 milligrams of cholesterol. And then by eating 3 eggs and 1 cupcake, a child consumes 836 milligrams of cholesterol. That one wants to know how much cholesterol is in each item. So numbers are cholesterol.
Let's do numbers.
Numbers?
Yeah.
That's probably the trickier one, because the other one you just have to write numbers, 4 pizzas, 3, you know, and go through it. This one you had to actually figure stuff out, okay? So here we go. The sum of 3 numbers is 58. The difference, so the difference of largest and smallest is 52. The sum of the 2 smaller numbers is 13, and then it says find the numbers.
You said it's 13.
Uh-huh. On one that said, yeah, the sum of the 2 smaller numbers was 13. So what I'm going to do is let my first column be my largest number, then I'll do my middle number, then my small number, then my answers. Okay? So this one just said the sum of 3 numbers. So I'm going to let that be x plus y plus z equals 58. So I'm going to let this be my largest, like I said, and then my smallest. That way, when I get these other 2 equations, I got my place values are right, okay? So the difference of the largest and smallest is 52. Well, my largest number is going to be my x. The difference, they want me to what? Subtract. So it's the difference of the largest and the smallest, which is my z. So that's going to be a negative z. Right? So my largest minus my smallest, we said was going to equal 52. Then y'all finally, the sum of the 2 smaller numbers is 13. Well, my 2 smallest would be my y and my z. So I know that my y plus my z is going to equal 13. So I now have equation 1, 2, and 3. And so this one sort of goes back like the others. Although the difference on the one I just did, we had all the A's were the negative A's, and now it's all the Z's. But I'm going to show you a trick on this one.
So we're
I could knock out these Z's really quick, but I've got missing variables here. I'm going to show you a trick. I'm going to get rid of one of these X's or one of these Y's. So I'll just knock out the X's, okay? But if I want to get rid of one of these X's, I'm going to multiply one of these rows by -1, okay? So I'm going to multiply row 2 by -1. And then add to row 1. Now I'm just wanting to show y'all, there's different ways to do these. Since this one was similar to the angles and we knocked out the A and negative A and A on that one, I wanted to show y'all when you got 2 variables, this sort of goes a little quicker. So here we go, multiply row 2 by -1, so that'll give me a negative x plus a z is going to equal a negative 52. Then let's bring row 1 and add down here. So I got an x plus a y plus a z is going to equal 58. All right, so notice my x's are gone. So I get a y. Z plus Z gives me 2Z, and then negative 52 and 58 give me 6. So equation 4 is what? Y plus 2Z equals 6. Y'all guess what? I've got a Y and a Z in this equation. I've got one over here with a Y and a Z in it. I've got equation 3, right? It's sitting down here with a Y plus a Z equals 13. I'm going to let that be 4 and 5. So you see, since I got rid of that one variable, I was left with two variables that was the same as another equation in there, okay? So we could have added two of these and come up with the same type of scenario, but why do that? We got an equation that's got what I need, right? So y'all going to get rid of the Y or the Z on that?
Y.
All right, I'm going to get rid of the Y. So I'm going to multiply. So you're saying. So to get rid of the Y, I'm going to multiply row 5 by negative 1 and add the 4. So here, that's going to give me a negative Y minus a Z equals negative 13. Row 4 was Y plus 2Z equals 6. But watch how nice this works out. The Y's are gone. Now, the reason I picked that other one, the reason I multiplied this one by the negative, because look at that, what's that negative 1 and that positive 2 going to give me? A 1Z, right? Now, if I'd made the other one negative, it would have left me a negative at that point, and I would have had to divide that negative out eventually. All right, negative 13 and 6 is a negative 7. I know the Z. I can go to either 4 and 5 and get the Y really quick. So I'm going to use this one right here. It's pretty quick, right? I got a Y minus my 7 is going to equal 13. So that's what Y is now, a 20. Now here's what's nice. You know the Z and you know the Y. But right here, I can substitute in for that Z and get that X pretty quick. Or I can add them all up here, it don't matter. So this is pretty, where was I, right here? So watch this, I got X minus my Z, which is negative 7. All that's going to equal 52. So just be careful on your signs. You're subtracting and then you're adding in that negative 7, okay? Which make that an X plus 7. Then my last step, I'm going to subtract that 7 and be done. So X is now, what's that, 45? So my numbers are 45 for the X. My Y went right here, which was 20. And then my Z was a negative 7. Internet issues. So y'all good on those? Trick on these just to figure out the equations you need and then solve them. All right, so let's look at the 3-7 systems of linear inequalities. So you got like 3 or 4 problems where you got a graph and inequality, and then one where you got to solve a system of inequalities, okay? So I'm going to refresh on graphing just a linear inequality. So these would be like graphing lines, except we're going to shade these. Because less than and greater than, you can have more than one answer for these, okay? I don't remember if y'all ever remember shading graphs. Well, y'all have to, okay? So the first thing I got to figure out, does my graph have a solid line or does it have a dotted line? So if you got greater than or equals or less than and equals, you will use a solid line. That solid line means that any number that's on that line will make it equal to it or greater than or less than, okay? Solid lines are like the solid dots when y'all did the x-axis stuff. You have hollow dots and solid dots. Now, if it's just a less than or a greater than, we're going to use a dotted line. And y'all remember, MATLAB will make y'all choose between them 2 lines, okay? By default, it's on the solid line, so if you got a dotted one, you got to change the line to the dotted line, okay? So now we got to figure out, are we going to shade above those lines or below the lines? If it's greater than or greater than and equal. So basically, if it's greater than, you're going to shade above the line. And then y'all finally, if it's less than or less than and equal, less than shades below the line. All right, so here we go. Y is greater than x minus 4. So think about that. There's a lot of infinitely many answers that Y can be from that x minus 4, okay? X can be a lot of numbers. So, I'm just going to come up with a graph so I can get me a line graph, okay? So I need to get this line graph. All right, so let's see. Give me 2 numbers.
2 and 6.
2 and 6. So how did you get the 2? It'll work. I'm just wondering what made you pick 2.
-4.
2 minus 4. So that 2 minus 4 here would give me what, a -2 for my Y?
-2.
And then if I put the 6 in for the X, 6 minus 4 would make that Y value +2, right? But y'all, any numbers would have worked. So let's get the line going. You did good though, you get my numbers pretty small. I don't like going out real big on my graph. So 2, -2, go right 2 and down 2. So I know I got 1 dot right here. And then you gave me 6, 2. So that'll be outright 6 and up 2 for my second dot. So now comes the main first question. Do I want to make that a solid line or a dotted line?
Dotted.
Dotted. Because I got one of them 2 situations, okay? So you'll come in here and make a dotted line. I want to shade above that line or below that line?
Above, because
Above, there you go, because right here we got greater than, and greater than shades above. So you would come in here and shade this whole graph above that line. Now on MathLab, once you get the line, they got a paint can. You grab the paint can and put it above the line, and boom, it'll shade it for you. Okay? But notice, any point that is shaded makes this true. Any point not shaded makes it false, and the line is actually false.
The straight line?
The dotted line, because it don't have that equals on it. If it had equals, then the line would make it true, but since it didn't have equals, anything on the line is actually going to be false on them, okay? So, questions on that? Those ain't too bad.
So when we use our numbers to put in there, we're gonna see what the equation says, like y is.
Yeah, they're gonna give you that.
4, and we're always gonna choose whatever random numbers we have, but we wanna keep them small and closer together.
Yeah, because I think the MathLab usually goes, what, about 10 on them graphs, 10 by negative 10, 10,
10 by
or something like that.
So like we do the same process if it's like, if we chose like 2 and 3, or
Yeah.
1 and 1.
And I just sort of focus on this part, see how big that's going to make my numbers. But since you're subtracting, I'd probably use any x's from 10 down, just to keep them. I like to use a lot of zeros and ones myself, you know, because 0 minus 4 and then 1 minus 4, those are pretty small numbers and stuff. So, but y'all are at the liberty to choose whatever you want. Okay. So I'm going to do one more, then I'll show you a system. So this one is x is greater than or equal to a negative 2. And this is probably the only one your calculator can't graph because there's not a y variable and it's an x variable. But there's 2 special lines when you graph. One is a y equals a number. If y equals a number, you're going to get a horizontal line. Okay? And if you get x equals a number, it is a vertical line. Okay? Now what that means is, when we give you something like this, x greater than or equal to number 2, negative 2, that means automatically that every x value has to be negative 2. Now, you can choose any 2 numbers you want to put in for them y's.
0 and 1.
0 and 1. So, we chose 0 and 1 because we like them. I guess I don't know. But you can choose any numbers you want, but the x is always going to be like it says, negative 2. I guess I lied about the graphing because we did have graph, and I forget about this section. But y'all want MathLab, what I would do, come over here to negative 2 on the x-axis, put a dot, go up 1, go put another dot. Okay? As long as you're exported as a negative 2. And it's going to make a vertical line for you when you put them 2 dots there. Solid or dotted?
Solid.
Solid. So this time I would have a solid line coming down here at negative 2. Which means now, since it's solid, anything on that line makes that a true equation. So, are x is greater right or x is greater to the left? To the right. So, and actually I'll show you a trick. This points the way we're going to shade. So since it's pointing right, we're going to shade to the right. So we would just come in and shade all this. Okay, I'm going to show you. This point was negative 2, 0. is -2 greater than or equal to -2? It's equal, so that's why the line makes this one true. Anything over here I didn't shade, anything over here would be -3x's, -4. Well, they're not greater than -2, they would be less. You know, anything that way is definitely going to be greater, okay? So one note, then we're going to do the double shaded. The solution to a system of inequalities.
Is it still 370?
Uh-huh. And 3-7 is the last section before test 1. So next week we'll be doing our review. I'll open up test 1. It'll be online because everything's online. We will sort of get into the second test material. So the solution to a system of inequalities is the double shaded regions. So one graph will shade one way, the other graph might shade the other way. I'm looking forward to where they overlap, okay? So solve. Y is greater than or equal to x plus 1. Y is less than or equal to 1 minus x.
You said x plus 1, that's a 2.
I'll have 2 of them, but I'll put a 1. Hey, I'll make it a 1 now. I don't want y'all get no grass saying, well, damn, how do you get a 1 on this? It should be a 2 or something, right? So really, you got to graph 2 lines, and we're looking for where we get double shading. So let me put some lines over. So I'll do my first one here with my X and Y, and then I'll do this one here with an X and a Y. I'll make a video for y'all for the calculators because they're pretty nice on the calculator. You can shade things up, especially if y'all got the new calculators like yours. It'll color them. It'll make one blue and one red or something, and you look for the double shades. Our old school ones just do everything black and white. Well, hell, I'm going to pick 2 easy numbers. 2 ones are easy. So I put a 0 in. 0 plus 1 is 1. I put a 1 in. 1 plus 1 is 2. So let me graph that first line real quick. All right, so I got 0, 1, which is sitting right here on the y-axis. And then I ended up with what, a 1, 2. So I'm going to go right 1 and up 2. That line, do you want that one to be solid or dotted?
Dotted.
It's going to be
Solid.
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 Because you got that line under there, remember? So that was definitely solid coming up through there. So now let me pick 2 numbers for this one. Hell, 0 and 1 works again. This time when x is 0, 1 minus 0 gives me 1 for the y. When x is 1, I get a 0. So boy, they're both coming right to this point right here, 0, 1 again. But now I got a 1, 0. Second line is coming down like that. Is it going to be solid or dotted? Solid, because it's got the equal line on it again. So solid line coming down this way. Oh, hell, I didn't shade the first one. Y'all told me it shaded what? This one, above or below? above. So that is shaded above, so it's all shaded like this. I used to have other colors in here, but oh well. Oh, there is a blue. So that was this line shaded above. Now I got this line right here. Is it shading above or below? Is it on the second one? It's got a less than, so it is definitely below. So that line came right here, remember? So I'm gonna shade it below. So below this line, would be like that, right? Can y'all tell where the double shaded area is? So this solution, when they give you the solutions, it's gonna have a picture of 4. It'll have this section colored, probably this section colored, probably this section colored on one, and this one on one. We need the double shaded area, which is right here, which would be from here to right in here. Anything in this section makes both of them true. All the other 3 sections, this will make one of them true, but the other one false. This will make one of them true, but the other one false. Okay? So I wish I could get my thing over here working real quick. I'd like to show y'all something. With the internet issues.
Hey, Mr. Rathfin.
Yeah, I hear you.
Hey, will I be able to see the rest of the board like on the video like that you make for us? Because I can't see like the whole board. I can just see like.
Oh, right now you can't. Let me go. Oh, so did my share quit going on while I was teaching?
No, nothing happened. There it is. I can see it now.
Yeah, but okay. I'll look at the video and see if my video messed up. I'll make my video for my next class and then I'll send that one.
Okay.
Because I know something went off about halfway because my main TV went back to screensaver mode. So I think our internet might have messed that up. So if that video's bad, I'll send y'all out another one today too, okay?
Okay, thank you.
All righty. All right, so that pretty much covered up everything for test 1, okay? So we review next week. On Monday, I'll review, open up that test, and then Wednesday we'll get into new material, okay? No, once you start a test, it's gonna be on I think they're like an hour and a half time limit or something like that. But you gotta get it knocked out and done. 25. Yeah. I might even tone it down, but I think I got it at 25. Well, some of these problems are pretty long, you know. All that inverse function stuff y'all was doing, the systems of equations y'all did, the composition of functions, the f of g's and the g of f's and stuff. So yeah, we'll get y'all going. So all right, y'all, if this video ain't good, I'm gonna send another one later.
Okay, thank you.
All righty, so let me make sure I got everybody here. All right, I got everybody, so I'm gonna quit recording and